Hello, welcome, very good morning here now. So you can listen so many voices which are beautiful and attractive, like you can listen now, right? Yes, so it is very good morning here. Let us remember what we were discussing in the last video, that is, we were discussing about path length and displacement under motion in straight line. We were discussing about path length and displacement. We defined these two physical quantities, and now what we do is we will try to understand that better with one example. Okay, so what I will do now is just imagine this is a path, and in the path I mark 3 points A, B here, and C. Okay, 3 points, 3 positions A, B, and C. I just take distance between A and B. This straight distance, the shortest distance is, say, 10 meter. Just imagine 10 meter. And this distance between B and C, the shortest distance here, is say 20 meter. Just imagine, so 20 meter, 10 meter and 20 meter. And you just imagine an object is traveling from A to B, then B to C. An object is traveling from A to B, then B to C. Okay, so can you say what is the total path length? Total path length or total distance, that is 10 plus 20, right? A to B means 10 meter, B to C means 20 meter. So total it is 10 plus 20, that is 30 meter, isn't it? 30 meter. That is the total, what you call, distance, means path length. And now suppose if you just imagine what is the displacement in this case. In the same case, what is the displacement? So actually what is the displacement? It is the change in position, right? So change in position occurs between A and C. Initial position is A, right? Initial position was A and final position is C. So what is the displacement? Again, here also, that is 10 plus 20, 30 meter. 30 meter only, isn't it? 30 meter only in this case. And then, suppose if you consider the object is moving from A to B, and then B to C, and then it goes from C to B again, C to B. Then what is the path length? Can you say what is the distance? See here, when it goes from A to B 10 meter, B to C 20 meter, so 10 plus 20, 30 it becomes, then again C to B 20. So 30 plus 20, that is 50 meter. Path length is 50 meter. Path length is 50 meter. And what about this displacement in this case? The initial position is A. Obviously, the initial position is A, and then it goes to B, then to C, then again to B. That means final position is B. Final position is B. So change in position occurs between A and B, right? So don't consider the path actually, because final position is B. That is only needed for calculating the displacement. So what is the displacement here? The shortest distance between A and B, that is nothing but the displacement, isn't it? So that is 10 meter here. Just remember, it is 10 meter, not 50 meter. It is 10 meter. See the difference. Then suppose if you consider, what do you have to consider? Suppose if you consider uh, the object starts from A, then go to B, then to C, and then returns back to A again. Okay, understood. Starting from A, go to B, then to C, then to B again, and then to A. Right? In this particular example, what is the path length? Can you say? What is the path length? 10 meters here, 20 meters here, again 20, 10 plus 20, 30, again 20 means plus 20, 50, plus 10, that is how much? Totally 30 plus 30, 60 meters. Correct? It is 60 meters in this example. And what about the displacement? Displacement. What is the value of displacement here then? Displacement is, initial position is A, final position is A again. So there is no change in position actually. Right? There is no change in position means displacement is 0. Displacement is 0. So you can see the difference. In the first example that we have taken, what is the case? The object goes from A to C. Correct. A to B, then B to C. That means A to C. So what is the path length? 30 meter. What is the displacement? 30 meter. And in the second case, we considered object moves from A to B, B to C, and then again C to B. So in this case, path length was 50 meter and displacement is only 10 meter. And in the last example, we have taken object moves from A to B, B to C, then C to B, and then again B to A. So initial and final positions are same. So the path length is the total path length, that is 60 meters, and displacement is 0 meter. Means there is no displacement because initial and final positions are same. Correct. So from this we can understand better about the path length and displacement, and their difference can be understood easily. Correct. So from the point of view of examination, or if you talk, you have to know, you should know the difference between path length and displacement. This is usually asked for 2 or 3 marks. Then you should know some differences between path length and displacement. You can see here some differences are given. Path length. So in the difference, you can write the definition itself as the first one. The total distance traveled by an object is called its path length. Okay. Then under displacement, its definition, this is the change in position of the body in a particular direction. Then the second one, it has only magnitude, so it is a scalar physical quantity. Okay. Then second one here, it has both magnitude and direction, so it is a vector physical quantity. And the third difference, it is always positive. It is always positive, and it may be positive or negative. How it is? It may be positive or negative. In this example, you might have seen. In the second case, how you get this, 10 meters displacement is 10 meter. What was the case? A to B. Object travels from A to B, then B to C, then again C to B. Correct. So how you get 10 meter here? You take the direction, that is this direction as positive and the returning direction as negative. Correct. So while taking this right way direction as positive, what we get, that is we consider the traveling of object from A to B is 10 meters plus 10, then B to C, plus 20, 10 plus 20, 30. And while it returns back to C to B, we take this path as this direction as negative. That is why we deduct 20 from 30. 10 plus 20 minus 20. That is why we get 10 meter, right? Should I write here? That is 10 plus 30. What we do? 10 plus 30, sorry, 20. 10 plus 20 plus, that is minus 20. Correct? 10 plus 20, not 30, it is 20. 10 plus 20 becomes 30, minus 20, it becomes 10 meter. That is why we got 10 meter. So you can see here, this while returning, we take it as negative because it has direction. That is only said here. In the third difference, you can see that. Path length is always positive, and displacement, it may be positive or negative. And last one, path length is always greater than or equal to displacement. Is it so? Path length is always greater than or equal to displacement. In the first example, we have seen here, path length and displacement are equal. And here, path length is greater than displacement. Here also path length is greater than displacement. So that is said here. Path length is always greater than or equal to the displacement. Displacement is always lesser than or equal to the path length. Okay. So these four differences, if you remember, obviously you can get the marks. 2 or 3 mark question it may be. So if it is asked for 2 marks, only 2 differences they ask. And if it is asked for 3 marks, you have to write 3 differences. So mainly you have to remember 3 differences. If you remember 4 differences, then any 3 you can write easily, isn't it? So do that to remember about the differences between path length and displacement. I think you understood better about path length and displacement now. Okay, thank you.